So today we'll start with the introduction part. So SolidWorks introduction, basically what we can do in the SolidWorks. Okay, what the SolidWorks software is. Okay, all things we'll discuss. So SolidWorks, basically what we are going to do in the SolidWorks in our sessions, we are going to learn about designing part, like how to be designed by part modeling, how to be designed by surface modeling, how to be designed by surfacing, and how to assemble the parts and all that. We're going to see how to make a drawings and all. So basically general process like that you can follow in SolidWorks. What like you can do, you can design your component, you can document that part. Okay, you can designing it. Visualization means that we have to represent like in the form of videos, in the form of pictures, right? That will be called rendering. So we design the part, we make a visualization, we do the simulations. Now here, if you see this image, what it meaning here, it's a meaning like we can check a mechanism, the mechanism that we are creating, the assembly that we are creating, that is movable or not. Okay, that is mechanism is exactly functionable or not. Okay. Then finally, once we all things we checked it, we'll go for the documentation part. Documentation where we used to produce the 2D drawing and we represent in the form of different views. So I'll just come to more detail. Okay. Now, if we talk about this software, okay, SolidWorks, which company product it is? It's a product of Dissolve System company. Earlier, it was product of SolidWorks Corporation. This was one university is called Massachusetts University is there. One graduate is there, John Histrick, who have produced that software in November 95. That was the first version was launched in November 95 at the time. Now, what the latest version in the market that is available? SolidWorks 2025. Okay. So now, in the software, we it's not limited to CAD only, as I mentioned. It is we can do CAD also, we can do CAM also, we can do CAE also, we can do like a rendering part also. Like you can say, it's a complete one package. With that one single software, you can do everything actually. But it depends like in which industry you're going, they are using at that level or not, because sometimes some industry only using it for particular specific task, and some because they have a different products are available in the market. Okay. So maybe like you are like currently working. What is the status right now currently?
Yeah, I'm currently working as an AutoCAD document in manufacturing.
Okay. Fine. So like if you have seen that environments, like some companies are only using a particular portion of a software. Okay. Like if we go to AutoCAD also, they will be not going to much part. They're using some of the specification daily basis. They're repeating that task. Okay. So full flange, we can say all portions of the software might be not get used. Right.
Yeah.
So like there's a wide variety of industries are there who are using this product. Okay, we'll talk about that. Now let's talk about hardware requirements. Okay, right now for this training purpose, I'm going to use SolidWorks 2024 version. Okay, if you want to install the same version or you have the version or you want to install the version, so what should be the system requirement is required. So you can use Windows 10 or 11, any Windows you can use it. Okay. So minimum like there should be some graphics card should be there. If you need a better working for the graphics. Minimum if you want better smoothness working, go with the 16 GB RAM. We can go work with 4 GB RAM also. But what happened? It will be work slow. So we want smoother working, right? 8 GB, 16 GB, at least it should be there. If you have, that is good. If you don't have, then you can try to be, if you can optimize your laptop. Okay. So you can just go to market and purchase some extra RAM and SSD, something you can inbuild in that, right? So that will be solve your problem. So minimum like 15 GB to 20 GB file size is there when you're going to download it and install it. That will be something that size of the file size you required. Okay. Yeah. So now we'll talk about some of the basic terminologies we have, like CAD, CAM, and CAE. Okay. So we're going to talk about these definitions. What are these? CAD, CAM, CAE, PDM, and design process. First, CAD. CAD means computer aided design, or CADD stand for computer aided design and drafting. So what we are doing here, we are making a views, maybe 2D document we are preparing, okay, by using 3D software or by using a 2D software. Like you are already familiar with AutoCAD, right? That is what basically a CAD product. Okay, it's a CAD technology. Under that, one software is coming, AutoCAD. Similarly, SolidWorks is also a CAD product. Okay, our CAD under the CAD technology, it's a application that we are using it. So like this kind of drawings that we can produce by using AutoCAD, CATIA, SolidWorks, Creo. There's a lot of CAD products are there in market that can be used. Now, let's talk about something about CAM. Okay, so basically, what is CAM? You know anything about CAM?
Yeah, it's like automatic. The computer will manufacture.
Computer manufacturing.
Without
Okay. Yeah. So what we're doing, we are
touching.
using computers to create a program, right?
Yeah.
So what we have to do, what is the workflow? We just create a CAD model. We can use SolidWorks. We make a CAD model, and that CAD model will be sent to the manufacturing field. Like we can use any manufacturing software, or we can use the same SolidWorks also. The SolidWorks CAM is there. We can use the SolidWorks CAM. From there,
Okay. The
we
for CAD
yeah
and CAM.
yeah CAM.
Okay.
Okay. So what you can do there, you can generate a codings. You can make a tool path. You can define a tool, then you can define which operation you have to run, and then you can make a program. And that program we can take from the software and we will feed into CNC machine. And then finally our job will be completed. So that will be the
Okay.
workflow with the CAM technology.
It's a part of CNC only.
Yeah, it's a part of CNC.
Okay.
Then next definition we'll understand CAE. So CAE stand for computer aided engineering. Okay, so here what we do analysis, like you're talking about ANSYS, right? ANSYS is what basically it's a CAE technology. It's a CAE product. So what we doing in CAE actually? What are the subjects we study? Like throughout our life in engineering, we have do the study. Like we're going to study HMT, we study mass like HMT. We have studied like material strength of material. We used to study. Then we
Yeah.
study like thermodynamics, right? A lot of subjects we used to study, and we do the calculation. Their manual calculations to calculate the problem by putting a formulas. So same
Yeah.
study we are doing on machine by using the CAE softwares. That is a
Yeah.
like what we're doing. We are checking like we checking simulation, the behavior of the component under such real-time condition, how the component will be behaving. Then on the basis of the results, we are optimizing that. Optimization means like we want to reduce the mass. We want to, according to volume, according to mass, we have to reduce the weight and everything. So we can do the optimization with the help of softwares. So that you can do in CAE products very easily.
Okay.
Now, one term is there in SolidWorks, it's called PDM. PDM stands for Product Data Management. Okay, in SolidWorks, what you can do, you can manage your product actually. So we can create, maintain a single document and a vault that can be accessed by a user to store and retrieve files. So basically, you can say PDM is like is one kind of vault system where you can store your files and you can take your files. So one thing is it is secured. Okay, it will keep your data up to date and accessible. We can easily access that, and it also eliminating the duplicate work and delay and saving the time and development cost of the company. Now, how it will be helpful? For example, a design engineer working on one project and he will save the project and he will give to the vault, means he will save into the vault. So vault, like it one person, the main person, the engineer, a manager, we can say, who have a like rights to be control the things, right? He can like share the file as he want to with him, or maybe other engineer who doing simulation. So what do he have completed his work? He saved his file here. Now he can allow the simulation engineer to do without making a new file. He can take this file and he can use this file, complete the simulation, and again save this work again. Again, any person who is from evaluation team, he have to check the data, he have to measure the things. So again, he can give the permission to this person. He can take the file and save it back. So this is how like what we're doing. We are managing everything in the product. We are saving the file at one location. So the duplication and everything will be stopped, and the time will be like increase, or like we can say reduce to do this process. In the basically in this industry, they have this connection kind of thing. Vault, actually they required a special user logins and all. Okay. So if you have that logins and all, you can put the logins and you can do this PDM process. So normally we are not using it. Okay. Now talking about product lifecycle management. So generally how we go with the product lifecycle management. First we define something we have to create, then we ideate that, and then we design, test, and produce that product. So if I go in more depth, so what are the process we used to take? So first part, we have to, like any company is making any product, what they will do actually? They will find a need. What is the need behind making any product, right? So they should have a need, requirement, thought, idea, something there should be there. Once like a need is generated, then what the second step? Second step is what we have to generate a concept. According to the need, we have to generate a concept. So that says we can say conceptualization. Okay. So once concept you can prepare by using roughly, you can take a paper and pen, you can use some softwares. Okay. With the help of that, you can generate some rough concept. Once the rough concept is ready, you have to finalize that concept, right, into a design. So we use 3D modeling technique that is called 3D modeling. Okay. So 3D modeling we do with the help of 3D modeling, we make CAD models, we do designing. And once the model is ready, now what we have to do, we have to test the product. Okay. So that stage is called validation stage, simulation stage, validation stage, where we are checking the result on our product. Once the result come okay, then we'll move forward to the next step. Otherwise, we'll go back. If the result is not okay, we have to go back to the design stage and we have to check our design. And again, we have to do the corrections until we are not satisfied with the result of the validation. We do not go to the next step in industry. So once that is finalized, you will go for the documentation part. Means you're going to produce a document. That document will be sent to the manufacturing team. And then manufacturing team will be manufacture your component. Okay. And then finally, it will send to the marketing team, or we can say we are using one portion of the software, a visualization where we can produce a render images, videos, animation videos to marketing. Okay. So this is how any product, any product that we are using in market, this is how the industry is working actually. So any industry will be coming in the market, there will be need. That's why they are there. Okay. They have ideas, they made in concept. Okay. They have a concept and they had converted the concept to design, and then finally the outcome is there. So this is how any product life cycle goes. I hope it is clear.
Yeah. PDM is different and PLM is different.
PDM is different and PLM is different. PDM is what basically that is a tool that we are using in the software, but this is not tool. It's a product life cycle. Okay. So this is a product life cycle management. It's not a tool. It's a life cycle of any product.
Okay.
So that is a data management. Okay. So what we are doing, we are creating a document in software. That is data is what the document is what data, right? So that document, how you're going to manage that document in industry between multiple engineers. So that will become under product data management.
Okay.
Now next is like I have mentioned on this of like according to this technologies, what kind of like softwares you can use it. Okay. Like if you preparing some rough concepts, you can use some softwares like AutoCAD, ZWCAD, Arrays Commander. Okay. That's for 2D based product. Okay. Like we know AutoCAD. So you can easily use ZWCAD or Arrays Commander kind of products because that are similar applications. Different competitor, different company, but same type of working, same type of shortcuts way to use it.
Okay, but I
there are
think
a lot of
AutoCAD
other
is
products
best
are there. Huh?
But I think AutoCAD is best among all these 2D.
Yeah, AutoCAD is best because AutoCAD have that improvement in design. Like if you see the interface, the working style of AutoCAD, that is more flexible, that is more smooth as compared to other products. But some companies, what happened due to license cost and all, na, very small companies and all, they are using this kind of products also there. Okay. So they also support the DWG, okay, like AutoCAD. So whatever we can do in AutoCAD, that we can do it like in other products, but we can say that these products or these companies are not that much developed like a Autodesk application products.
Yeah.
Now, if we come to 3D modeling, okay, 3D modeling. So we can use CATIA, Creo, NXCAD, Inventor, SolidWorks, Fusion 360, okay, Solid Edge. There are a lot of 3D modeling products we have that we can use. These are most popular software that I mentioned in market that is used in designing. Then
Okay.
coming to simulations like ANSYS part, right? So there you can use ANSYS Workbench for structural testing, ANSYS Fluent for fluid testing. Fluid means like CFD, fluid, like wherever you have like gases, water, like any kind of liquids that is there. So that kind of flow testing, velocity drop, pressure drops, laminar flow, turbulent flow. Okay, so that kind of study that we do in fluid mechanics. So
Yeah.
that we can do in ANSYS Fluent. Then one product is called Hypermesh, which is used for meshing purpose. Then NX Nastan, again, this is a complete product for using simulations like ANSYS Workbench. Again, it's an advanced level product. Then manufacturing, what application you can use, like NX Cam is there, Mastercam is there. This kind of products are there that you can use for manufacturing purpose. Now for documentation, what you can use it, like whatever the software I mentioned in conceptualization and design part. So that all softwares you can use it in the documentation part. AutoCAD, CATIA, Creo, and XCAD, that all softwares we can use for documentation purpose, because we can make a 2D drawing by using AutoCAD also and other 3D product as well, because we make a 3D model and from there we can convert into 2D drawings.
Okay. So documentation means what are the steps you have taken in drawing that product?
Documentation means like basically in our case, according to software case, we need a 2D drawings, like which will be having a views with dimensions. Front view, top view, right view. That will be have a full detail of the drawing. What is the size? What are the tolerances? All that will mention in that part. So that will be called documentation.
Okay. So it's not including all the commands you have used, all that
No,
also
no,
is
no.
given?
That not included in this.
Okay.
Next will be visualizations. So visualization means like we have to produce rendering images, high quality images. Okay. In that cases, you can use 3ds Max Keyshot. Now, if you talk about SolidWorks, there is one part is there in SolidWorks, or you can say it's separate application with SolidWorks it get installed. It's called SolidWorks Visualize. With the SolidWorks Visualize, we can do that kind of work also. We can produce higher quality images of any product that we are designing in the SolidWorks. Okay, so that is about product lifecycle management. Now, design indent. So you know anything about design indent?
Design intent. What purpose they are designing or something like that.
Yeah. See, yeah, you're so correct. Like anything we are designing, so what purpose we are designing and what is the process of the designing that we have to follow. Okay. So because if we have a purpose, then we will plan accordingly to design that part. For example, I have to design a simple bracket. Okay. So like my need is what I need to design a bracket which will be have a center hole. So how I'll go that I have to go like process accordingly. I have to make one sketch, a rectangle sketch. Then the rectangle sketch, I will add some material. Then I will cut the material from the center with the circle command by making circle and use extrude cut command. So that will be a process that I'm following for a purpose that we have made the part, and that is clear that what we have to do, how we have to do. So that is called design indent. Okay. So you can see design indent is how your model behaves when dimensions are modified. So what it means actually. So whenever we're making any model, right? So we have to take care of these things also, that if we modify the model once we create it, so that will be modified properly. It do not make errors. It will be rebuilt properly, rebuild means update properly. So without making any errors. So here, like here you can see one example. Like we have one hinge is there, right? This hinge. So we have some hole with like it's have some size, specific size. Okay. So I created a complete component. Later I realized that that size I needed for this part that is small. Okay. So we have made in such a way that if we change like something that will be equally changed everywhere. Okay. So like you can see example, we have edited some distances between them. We have changed the length of this part. So here also the part will be get updated accordingly. So that will be a design indent. Understood? Now we're going to talk about some of the definitions like feature-based modeling. Okay, so like 3D softwares, what generally we use 3D modeling, so like feature-based modeling technique. Whatever the parts we are going to design, we have to use features. Feature means there is a commands like sweep, revolve, loft. Okay, so that all kind of tools that will be in the software that is called features. So whenever we designing a parts, we are using features by feature and we are generating our model. For example, you can take like yes, yes, Salman.
Yeah, still continue.
Yeah. So for example, if I want to make any component, like for example, the mouse I have to make, right? So how I'll make a mouse, I have to do a surface designing. Then for curves, I put some splines and then converting with some filling surface method. Then for rounding, we use some fillet method, right? We're using different commands together to complete one product. So that is known as feature-based modeling. So simple example, if we consider like assembly, assembly is what? Where multiple components we are bringing together according to their work position, and that will be called as assembly. Similar basis, multiple features when we create applying into the part to make one single part, that is called feature-based modeling.
Okay.
Now, feature-based modeling will be of two types. One is called sketch-based feature, and one is called applied feature. So what is a sketch-based feature meaning? Where we need to create a 2D. Like here, this is the block. So how the block is made? First, you have to make a rectangle, a 2D sketch. Then you're converting this 2D into a 3D. Okay? So it will be converted into a block. So I made a sketch and I have converted 3D. So that kind of command is called sketch-based features.
Okay.
So extrusion, revolve, sweep, loft, that are the type of tools that we are using to do this kind of processes. Okay. Now next is applied feature. Now what is applied features? Like where we have already 3D model. So we have, this is a 3D model now we have generated. Now what we want to round the edges. Like you can see here, these edges are round. So what we did, we apply fillets. So that options that we directly apply on the 3D model and it modify the model. So that kind of feature is called applied feature. Understood?
Okay. After the modeling.
Apply will be directly applying on the model. No need to create a sketch for that. No 2D is required. But in this, we need 2D, then we can make a 3D. But here we have a 3D. We are just doing editing on the 3D, we can say, or we can say modification. If I say simple, modification to the 3D. Okay, modify 3D by using fillet, chamfer, other tools. Okay. Right now in SolidWorks, we are saying this features to applied feature. The same names in other softwares like CATIA, we call it dress up feature. Dress up. Okay, same name.
Okay.
Name is different, thing is same. Okay, dress up feature. Somewhere you will heard this name like placed feature. Placed feature. Okay, same things. So if you hear this name, no need to worry. All thing is same. If somebody asks you in an interview what is this a feature in SolidWorks, you can tell them fillet, chamfer, shell, that kind of commands are dress a feature or place feature or applied feature. Same definition, only the naming is different. Okay. You have to remember these three names. Okay. Dress up, applied, and placed. Now next is parametric. Okay, so I talk about design indent, right? So it's the concept related to design indent only. Okay, So whenever we make model, we used to do dimension plus relation in SolidWorks. Okay, like this part that I've created now. So I have to make some dimension in this. Where's my cursor gone? Yeah, yeah. So we have designed this part, right? So there will be some dimensions we have made. We have added relations. So here, like you can consider this will be having a dimension of 10 mm, right? And later we realize that I don't need the size of 10 mm. I need to be make a hole of 6 mm size. Okay.
Yeah.
So what we did, we just went to that hole. We added the one hole, and all holes will be become to 6 mm because we applied a relation like that. So if we update one hole, that will be change every hole. Okay. Again, like there will be a distance there. A distance is there. We have more distance. We want to reduce the distance. So we go and we just change the between distance the part. So that part will be got modify accordingly. So this thing is called basically parametric modeling, changing with the relations and dimension, and that will be change your model accordingly. Understood?
Okay.
So same concept is called parametric modeling. Like you have heard about so many times, like this word, the parametric modeling. So parametric modeling softwares. So these software are parametric modeling. Why we call it parametric modeling? Because we can make a changes by editing the dimensions anytime, and that changes will be updated properly. When we make a part with properly following a design intent, relations and dimensions, so that can be possible.
Okay.
Now next term is called bidirectional associative. Now what is bidirectional associative? So like whenever we design a component, like we have this one part is there, right? This part is there. So we have produced a drawing document of this. Okay, you can produce drawing, plus even you can use this component in assembly. So later on you realize that whatever part I have designed it, and I don't need some of the portion from that. Like we can see there is a smooth edges are there. There's a fillets on that part. The smooth edges are called fillets. We have a fillets over the model. So what we want to do, we want to delete that fillets. So we went to the part again and we deleted that fillets. Once we delete the fillet and save the part, we will check that in the drawing that will be also get updated. So that process called bidirectional associative. Okay. So let me practically show you both the things that what I'm talking about. Okay. So what are I said, bidirectional, feature based, okay, and parametric, these all things, let me practically show you in the software. Okay, so here we have a software. Now we'll see. So first I told you feature based modeling. Okay, what is feature based modeling? Let's see. So first we have to create something. So if we create something, we can understand what is the feature. So I'll just make a sketch. I'll make any random sketch. Okay, let me add some dimension over the part. Making this to be equal with this, I'm putting some relation also. This is equal to this, so that will become equal. And this is equal to this. Okay, like this, I give some dimensions. Let me put some dimension here. Okay, it is already there. So let's put something. Okay, it's not taking. So let me define with respect to origin, this to be centered. Let's define some point, this point, and this point will be centered with the origin. Okay, now we have to define this height. Like this, I define some dimensions. Okay. So I'm just going to extrude this part. This command is called extrude. By that, we are just adding a material over the part. So right now I'm showing you introduction part. So not going depth initially. So don't worry about that, how I'm doing it. Okay. So I'll tell you everything one by one. So I'm just adding a material and just added some material on this. So I did one feature on this. which feature we did? Sketch based feature. We made a sketch and we have add the material, right? We can use again sketch based feature. I'm selecting this face. We can add a hole. I want to cut a hole. We can draw a circle and we can remove the material by using extrude cut command. Okay. So this is again a sketch based feature. So the two features I applied, that is sketch based feature. Now let me apply third feature, which I'm going to use directly over the model without making a sketches. So we have a fillet command. Let me take a fillet command. I said I want to make round this edges. Let me put the radius value to be 2 mm and do OK. You see, I haven't made any sketch. I just modify the edges. Okay. You can apply more features, like I'll take a shell command. I want to remove the material of this face and I want to make a wall object wall. So for example, I'm taking a thickness of 3 mm and do OK. You can see here, I remove the material from the body and become shell. So these two features are what basically? These are placed feature, applied feature, or dress up feature that we apply over the 3D model. Right. So that we understood. Now let's understand next concept about bi-directional associative. Okay. So let me make this component to drawing. So we can take here, make from drawing. We'll save this file as save here.
But can you show how to do that sketching? How to start that drawing?
That I'll tell you. Don't worry. Okay. So we'll go to file and we'll go to make drawing from the part. Okay, we'll save this and we'll save it. So here I can choose a paper, any paper I can take it and do OK. So I just added a model here. Okay. So let me add a dimension to view that what is the size we have taken here. You can see this 75 size, right? You can see this will be something 23. Like you can check the radius and all. You can see 2. Okay. So what I mentioned it in bidirectional, whatever we change in the model that will be reflected here. Now let's go to model. So you can go to Windows and you can go from here. Now I'll just modify the size. I'll say this to be 100. Okay. Now let's go there in the drawing. You see what happened here? It is also updated. So this is the meaning is called bidirectional associative. And we have seen parallelly parametric also. So I have changed that thing and it will be changed properly. But what is the problem came? This hole not arranged properly. Why? Because I have not followed the relations properly. So that's why the hole is not centered. Earlier it was on center, right? Like let's see undo. Center, right? But right now it is not at center, right? So why it has happened? Because while making, I have to maintain a relation in such a way that it should be remain at center of that body. So for that we can use some relation. Let's see, I'll show you. Initial, just put the relation with this edge and should be horizontal condition. And I'll just take one relation with this edge here somewhere with the point. And this to be vertical. Exit. Now you see, it was came in properly. Now, whatever the dimension you change, it won't affect. Like if I change again, I'll go here 150. You see, it is remain at center only. You can reduce it, maybe 80. You see, so these things are called parametric modeling. Okay, so we can easily flexibly change the model if we made it with proper dimension plus relations. Is that clear?
Yeah. Where is the option for parametric?
This is no option in parametric actually. See, whenever we make a model, now there will be dimension we did it, right? So when you click on these, you have the dimensions here.
Yeah.
So this you can just change it as you want. That is meaning of parametric. That is the meaning of parametric modeling. Clear, no?
Okay. No, how do you set the hole in the center for this?
How? That I did it with the relations. That I did with the relations. Okay. So that I'll teach you right now. We haven't started. I'm showing you just a little bit intro. Okay. So when we go to depth of that part, I'll teach you how to add constraint plus relations dimensioning properly, so you can able to do this. Okay. So right now only this introduction to understand how the parametric modeling can be made properly, how we can do that. So until we're not perfect in the relation part, we cannot able to make that perfect model with the proper parametric relations. Okay. So we have understood this one. Now let's go to. So in software we have is called constraint. Oh, I was talking about relation and constraint, right? So when we make a sketches, there will be some relation we have to use, like a parallel, perpendicular, horizontal, vertical, concentric. Like when I made the circle. So we have to use a variety of relations when we are making sketches. That is very important actually. So if you define relations properly, you can make your sketch to be definable. Okay, so that I'm going to show you, not now, but right now we only understanding theoretically what are the things are there, what are not there. So that you should know something constraints are there. Okay, so like you see that circle, what I did, I made it center that circle without any dimensions. So what I did it, I add a relations, I add the constraints. What constraint I use two constraint. One is horizontal and one is vertical constraint. With that, I have aligned that hole at the center with that face. Okay. Next, one feature of the software like is there. Like you know 2D, how to make a 2D. You can take a tool like, you know, the rectangle is there, circle is there. You can take the tools and you can draw 2D. Now you want to make a 3D, but you don't know how to, which command to be you have to use initially, right? You don't know. So what you can do, you directly make a model into 3D. I'll show you that feature, how you can use. That is called Swift feature. So that is called SolidWorks Intelligent Feature Technology. Okay, Swift means SolidWorks Intelligent Feature Technology. Let's see how to use that. So you're going to see here, I'm going to create, let's take any plane. First we go to sketch command and I'm going to take a front plane here. Let's draw a sketch. Okay, I made a rectangle here. Now this rectangle, I want to convert into a 3D. Okay. I'm not going to use a 3D command, but I will convert into a 3D. So I have to click on this. You can see one arrow came. Okay, I just pull the arrow. See, the material is added. You want to cut the material same way, you can do one thing, you can draw a sketch over the part, exit. Again, what do you do? Click on that and you can remove the material. See? Yeah, it is extrude and extrude command only, but we are doing without taking that command.
Okay.
So that is called Swift feature of SolidWorks. Now next, like if you talk about the practical application of the software, what kind of industries are there in the market who are using this software? We have variety of application areas there. Aerospace is there, defense is there, automotive and transportation. Okay, just a minute.
Yeah, no problem.
Okay. So you have automotive industries there, transportation industries there, okay, where we have to design vehicles, a car, okay, like any bike or any kind of like transportation objects we can design on that. Then consumer product we are what product that we are using day to day life. Okay, you can see in your surroundings so many like products we have. Like we can say, for example, I have a phone in my hand, that will be a consumer product. The mouse that I'm using as a consumer product. Like from morning to evening we are using so many consumer products. Like when we wake up we do the brush, that will be a consumer product. Okay, from morning to evening we are using so many consumer products. For that we need a different engineering, right? We need a different industry to make a product. So we have so many industries are there where we can make a variety of consumer products by using this kind of products. Then you have design and engineering service. Now, what does the design engineering service do actually? These are basically consultancy companies which they hire engineers to provide a service to the market. Okay. They do not do like any product development or any manufacturing or something. They just take a project from outside of the other countries or maybe inside the country, and they do work on that, complete the project, and they do a service like consultants, we can say that, right? Then electronics departments, what we can do, what mechanical engineer can do with the software, we can make outer casings of electronic products like CPU, inverter, AC. Okay, like some examples I given, electrical and electronics. So even there is SolidWorks. There's one part is called SolidWorks electrical. We can do wiring kind of thing. We can do PCB designing also, but that is not our part. That is electronics part. So, but that can be done in SolidWorks. Then you can make industrial machines. Then you can make a medical devices, mold design you can do in SolidWorks. Oil and gas industry components you can design in that. Packaging machines, that kind of designs you can do in that. Okay, so these are the areas, broad areas where this kind of CAD products will be useful. Okay, now let's talk about software interface. Okay, so that's the basic theory that I talked about. Now I'll come to directly to the software things. Okay, what is software, how it is. Okay, so SolidWorks, like it is very when you open the software, the graphical user interface is very easy. You no need to be like find so many things. It is easy to use. You can say that. Okay, so here in the screen you will see one menu bar will be there. This will be your menu bar. One menu bar will be have new option, open, save, print, undo, redo, then selection option, update option, and some setting options will be there. Then one more menu will be there where you can just click on the file button. It will be show you more option, edit option, view option, like that we have. Okay. Then you have one command manager where you have all the features, commands are available. I was talking about feature based, right? These are features. These all are all features. Okay. So we have a command manager. In that we have features and other tabs are available according to the tool requirement. We can go to that particular tabs and we can use the tools from there. Then we have a feature manager. Okay, feature manager is what basically whatever we doing designing here, whatever we making like using the tools, that all tools detail will be here in the feature manager. We call design tree in other softwares, but in SolidWorks the name is called feature manager. And like what are the features? Like for example, you do extrude boss command. You see the second option is there here. So this second option will be called a property manager. So it will be show you the detail of your command. You can see everything related to that command in this particular box. Okay, so that will be your property manager. Then in software you see there will be arrows will be there, arrow. What does arrow represent actually? That will be representing we have more commands inside that, we have more tools inside that. Okay, so you can click on that arrows and you can access the tools and you can use it actually from there. Now let me take, okay, we have this option. So this will be called a head up view toolbar. So this is, you can control view options directly. What are the view related options are there? Zoom in, zoom out, other option like color changes, background changes, okay, hiding and showing multiple views, sectional view. Okay, so that all related view things will be controlled by user head up view toolbar. Then mouse gestures are what basically with the mouse, by dragging the mouse, now you can get the options directly over the mouse. If you're working in 2D, it will show you 2D option. If you're working in 3D, it will show you 3D option. You see here, there's some sketch tool is there. Here some 3D options is there. So it will be behave accordingly in which environment I'm working. The mouse gestures, it will be automatically give the tools suggestions in which environment you're working. Okay. Okay, let me open and discuss that all things on the software. Okay. So whatever I was talking. So you can see the top, this is a menu bar file. You can have the options from here. File, edit, view, that is a one menu bar. This second menu bar is there, like this is a home tab and all. This is the second menu. You can unpin this. Like you can see, this is hide it. Only one will be remain. You can open that and you can pin it. It will be second will be there. Okay, so both you can keep or you can hide it one. So home, like other options, that other like open, save, print, redo, undo, rebuild options we have. Then this side, this option, like you can take file and models, you can access where you have saved from the model in your PC, you can get from here, you can search directly. or you can take a SolidWorks help if you have licensed connection. Then you can go for the command. Command means basically like any of the command you want to use it, and you're not able to find that command in the software. So best way is to, if you should know the name properly. Okay, if you know the name, for example, I'll type the name which is not directly taken. Like I'm taking here split command. I'll type split. You see there? Okay, so it will be show you the remaining options that we cannot directly see in the screen. So there are a lot of tools are there which will be directly not visible. There are different places we don't know where to go and where to take that. If you're seeing that command anywhere, you know that command is existing in the software. You can come and search here. You'll get the command. Okay, that is the easiest way to access any command. So this will be called your feature. Yeah.
I mean, it's not like command wave. Like in AutoCAD, we type the command and do the action.
So it will be not like that.
SolidWorks parent,
Yeah, there we have to type a shortcut and we can get the command. But here we don't have all the commands or shortcut. We have few commands. Few shortcuts are available that we can use it. Not all like AutoCAD. We can type L enter. We can active the command, right? We don't have that much level of shortcut because here we can directly pick a tool and we can work.
Okay, it's designed like that.
Yeah. Okay. So this will be your command manager where will be have feature tab. These are called tabs. Okay. So this tabs you can enable and disable if you feel I want to hide extra tabs. I don't want to take extra tabs. What do you do? Right click on that and you go a tab here and you can enable and disable. Like I don't need development. I don't need mesh modeling. Okay. So what are the tabs? I don't need it. I can remove it. And if you remove, for example, any extra tab that you needed, for example, let me remove sheet metal. I remove a sheet metal tab from here, but I need that sheet metal tab. So we can go back and we'll select the tab anytime it'll be come back. Okay. So that's the tab system. Now here, like, as I mentioned, whatever you are going to use, like we have made something here, right? We can see the detail of that part here. That is a operation detail. From here, you can control. You want to edit something, you can edit the sketch from here. You can edit that feature from here. Okay? You can go to feature editing. You can edit the feature. You can edit the sketches. So that is a history. So that will help you to control your the models that you're creating on the screen. Then initially in SolidWorks, we have three planes: front plane, top plane, and right plane will be there. Okay. Let me first let me discuss that, then I'll show you. So here, like it's called selection breadcrumb. Okay, that name is like that, selection breadcrumb. So what you do actually, if you want to search something like filter kind of thing, you can say, okay, you can type here. For example, I want to search front plane only. Okay, I'll type here front. You see, everything is hidden. What it's showing here? For example, I want to go for extrude command. I want to search extrud. I'll type it. Okay, so you see here, I type extrude. So related extrude, all the commands are visible here. So I did one, so one. So it's like you have so many features. You can rename this features actually. So you can type that name and that will be directly we will find that feature instead of searching. If you have bigger parts, because bigger part will be lot of features will be there. It's a smaller part, few features only there. So I'm talking about head up view toolbar. This is a head up view toolbar. So that will be used for like zoom in, zoom out. Okay, you can use area zoom in with this. You can take like this and you can use this to fit zoom. This is for sectional view. You can see the section of the model by clicking on that. You have different planes. By that, you can see different size sections of the model. Okay. Then here we have the option is called we can see different views of the model. Like I want to see the top view. I'll go to here. I'll take a top view. See this top view. Then you can get from like maybe you want to go to left view. You can go to a front view of the model. Okay, right view, and change like this. You can take different views of the model. You want to see the model in the two views, like you can take a two view horizontally. You see here, two different view. You can see right now you're seeing horizontally. You want to see this vertically, take the option vertical. Okay. And again, you can go here and you can just take four views you can take. Okay. Any model you're making and you want to see from all the views how it is looking. What you're making, it's okay or not, correct or not. So you can take help of 4 views to understand your model. One is isometric view, one is top view, front view, and left view.
Okay.
So I'll just get back to one normal view. Okay, so let's click on single view here. Then like you can also see your model in that wireframe form and like shading form. You have some options here. You have, this will be like right now you can see edges over the model, right? Edges you can see.
Yeah.
If I click here, it'll be hide the edges. See? Hiding the edges. Then you have option, you can see hidden lines removal. It will be show you like this. And you want to see the background lines, background hidden data, use hidden line visible. See, it will show you that, which we cannot see directly, that things we can see. Here, see, the whole cannot see directly from, but we can see. See. Then you can go to the last one. It will be wireframe. It will be show you wire, complete wire object. So these are visuals we need at different places when we're working. We can change as per our need. We should know that these tools are there. So we can change as per the need. Again, we can make it to normal one, first one. Okay. Now next, let's talk about some shortcut keys. Okay, how to use shortcut keys. If I press Z, okay, what does Z do? Zoom out.
You have to type it directly on.
Only press Z.
Yes,
okay, just
okay.
type. Type means hit on the button Z.
Okay.
So what happened? Zoomed out.
Zoom
If you want to
in,
zoom
zoom
in, what do you do? Keep on press Shift button and continuously click on Z button. Z. See?
Okay. So it will zoom in. It will zoom in.
Yeah, it will zoom in. Only Z will be zoom out, and Shift plus Z will be zoom in. Now next way,
Okay.
you want to fit the feedback model, right? Feedback. I already told you can fit from here, right? But you can press F. You see there, it will be feedback. So F will be a shortcut. With that, you can fit the model on the screen.
Okay.
So whatever I told you, you can take from here, right? This option. Then again, shortcut is there, space bar. If you press space bar, you see the same option will become. You can click by space bar and you can take from here also. Next, like when we working on face, like I did select this face and I'm selecting make it this face become flat to screen, normal to screen. We call normal that thing.
Yeah.
But what happens? Sometimes it rotate while making like this. If you create something, but by mistake we have rotated like this. Now how to take in the same position again? Normal view. So remember the shortcut Control 8. Control 8.
8.
I'm pressing Control 8. So that becomes flat to the screen. Or what you can do, sir, I cannot remember the shortcut, right? So what I can do more? See, you can see this icon is there in my PC, how it came here. You have to search in the command, search command normal 2.
Okay.
And you can click here directly and just drag and drop on the screen. Okay. When you drag and drop, it will be added here. So like this, any tool that is useful for you and which is not directly display in the screen, you can search and add it here. Okay. So you can use them. It's clear?
Yeah.
Next, if I press S will give you shortcut accordingly. You are in 2D or 3D, it will give you shortcuts you can use directly. For example, I want to make a circle. It given a circle. Now this face is already selected. Let's make Control 8, make a normal screen. I can make a circle. Again, I cancel the command by pressing escape button. I want to press S. I want to take a rectangle. I just take a rectangle. Again, press S. I want to trim them. I just trim it. So like this, you can directly take the tools from your screen itself. No need to go there. Okay, so you have to press S button.
S button.
Next,
Okay.
S. Okay.
Which button? S button.
Just a second now. S.
Okay.
Okay. If you press S, it will give you shortcut on the screen. Shortcut. So if I press S, it will become. Suppose you want to search any command. You don't have a command, you can search also. Okay. maybe I want to take like it's already all dimensions things are there. Let's point is not listed here, no? Point is there. Let's go to point, for example. I'll type point. See to search and come. Okay. Or what you do, see the plus here. You can click on plus, it'll be added here. Okay. And now you can use it continuously. You want to remove this, you can go to customize and then you have to remove that from there. Point. Okay, now you have to see how you build the point and all. You can remove also, you can search point and you can remove from. Okay, fine. Removing, let's leave that removing part. So like this, you can add a option in that and you can use that for future. Press S, now it is there. Okay, that is a benefit. Next, like if you want to go to recent document, like you have recently working with any project and you want to go to that project. Okay, you save that file in your PC and you want to open now recent project. You press R. So what R will do, it will be open the recent file here. See? So I can access my recent file by clicking from here. I say I want to open this project. It will be open. See? So R, and you can get to the project. See? Now, if you have opened multiple windows, like multiple files you have opened, multiple files, more than one file, you can press Control and Tab key, Control plus Tab button. So this will help you to go to one file, or we can go from window. Simple. Either use shortcut or either go from window method. Okay, I'll show you.
Okay.
So I'll press Control and Tab button. See here, it's only showing SolidWorks file. Okay, I can click by mouse. I can go to that file, this file, or this file. Three files are open. See, or just press Control Tab and just enter. Control Tab, select that file. Control Tab, like this. Or I told you, you can go to Windows and you can go to the document. Okay. Now let's understand. For example, I'm just make any command in 2D. For example, I just take a rectangle. Okay. And I cancel the command. See, my cursor is not showing now rectangle. Now I want to take a rectangle again. What I'll do, I'll press enter. My rectangle is active again. Okay. Means if you cancel any command, you're using it. Like again, I'm canceling C. And I hit enter button. It will be active again. So last use command, you can take it again by pressing enter button. Understood?
Okay. Okay. Same like no AutoCAD.
Same like AutoCAD. You can say by entering it, repeat the command. Okay.
Right.
Let's understand about mouse function. Okay. What are the shortcuts that remain? I'll discuss that. Okay, that is done. S is done. Okay, let's see. So now, like if I press Control Z was basically undo. Like I deleted sketch, right? I want the sketch back. I can press Control Z. See, it's come back. Again, Control Z you can do. It will be go back by step by step back operation. Okay. If you press Control Y, it will be redo. Control Z, Control Y. Understood? Same like AutoCAD, you can take from here also the same option, undo or redo. Okay, undo, redo. Control B is what basically, like suppose I'll try to make changes. Sometime what happen now? If you make changes in the model, it do not updates actually. Let's try. It's 44. Let's make this to 50 and click. It changed actually. If do not change, it's still changing. So if do not change, what will happen actually? I'll tell you. There will be one green and one red like dot like this will come here, like this symbol. Its symbol where it will come? It will come here on that particular command, which is not update on modification. So in that case, what you will do? You will just press Control B or you can click on this icon. Okay. If your model do not make changes that changes you're doing, in that cases you have to do this.
Okay.
Understood?
Yes, got it. So it will remove the error if we click on that.
Huh?
Will it remove the error if we just click on that dot?
It not show error actually, it will be update. It will not show any error.
Okay.
It just update the model. When you click on this now, right now nothing is to update. Okay.
Right.
So I'm trying to do, but it's not updating. But if any dimension sometime we change now, it do not changes. Like you made it, for example, 40, but actual model not become 40. But right now it become 40. But suppose you made 40, but it's not become 40. So in that case, you just click on that, it'll be update that. If it is not possible to make 40, means you made it 40, but actually it's not possible to do 40, then it'll make error. The software will make an error.
Okay.
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 So sometimes changes do not happen automatically. In that cases, that will be useful. Okay. Let's try to show you. Maybe I can show. Let me try. Okay, let's try to make this to be 50. It's happening actually. Sometimes it's do not happen, but it's happening now.
Okay. Whenever it happens, you have to click on or Control B.
If do not happen, you just press Control B.
Okay.
So, but it is getting update. Okay. So if not update, so then Control B is the option to update it.
Okay.